Welcome to this explainer. We're going to take a massive journey today, looking at the entire epic arc of NASA, from its really tense, kind of paranoid Cold War origins, all the way to mapping out humanity's survival out to the year 2100. It's a story of absolute triumphs, some truly heartbreaking setbacks, and a wildly ambitious roadmap for the future. So let's jump right in.
Okay, to really understand how this all started, we have to go back to 1957. The US and the Soviet Union were already locked in this incredibly tense global rivalry post-WWI. And then, the Soviets successfully launched Sputnik 1. Now, this satellite was literally no bigger than a beach ball, but it instantly triggered absolute geopolitical panic. The thinking was, if they can put a satellite in orbit, what's stopping them from dropping nuclear weapons across continents? And just like that, the space race was officially on.
So the United States is scrambling. They desperately needed a massive, undeniable win to prove their technological dominance. Enter President John F. Kennedy in 1961. He issues this legendary challenge that basically becomes NASA's ultimate directive. He famously declared, "We choose to go to the moon." He wanted a human on the lunar surface before the decade was out. At the time, that goal sounded completely impossible, but it absolutely galvanized the entire nation. But here's the thing, NASA couldn't just build a rocket and aim for the moon right away. They had to figure out how to basically walk in space before they could run. So the agency rapidly leveled up through three intensely complex steps. First up, Project Mercury. The goal there was just to prove Americans could actually survive in space. Then came Project Gemini, which is where astronauts mastered the really tricky stuff, complex orbital mechanics, spacewalks, docking ships together. All of that was the absolutely essential groundwork for the Apollo program, which tackled the massive rockets and the actual lunar landing systems. Of course, moving that fast was incredibly dangerous, and we really must somberly acknowledge that this rapid progression came with a heavy cost. In 1967, disaster struck during what was supposed to be a routine ground test fire for Apollo 1. We tragically lost 3 astronauts, Gus Grissom, Ed White, and Roger B. Chaffee. It was a massive wake-up call. That heartbreak forced a top-to-bottom, life-saving redesign of their spacecraft safety systems and totally transformed the engineering culture at the agency. Overcoming that immense grief, NASA pushed onward, and it all culminated in an unparalleled triumph on July 20th, 1969. Apollo 11 proved that human engineering could achieve the seemingly impossible. And by the way, they did this using flight computers that literally had less processing power than the smartphone in your pocket right now. When Neil Armstrong stepped onto the lunar dust and delivered those iconic words, it wasn't just a political win anymore. It was this profound, unifying moment that inspired generations of scientists all over the globe. Now, as we look back at this history, the crucial takeaway is that exploring the cosmos never stops being devastatingly risky. As NASA moved into the space shuttle era, trying to make spaceflight routine and reusable, they encountered profound tragedy once again. The catastrophic loss of 14 astronauts across the 1986 Challenger and 2003 Columbia shuttle disasters completely shocked the world. These events starkly exposed some really critical, deep-rooted flaws in the agency's decision-making and safety culture at the time. But despite those harsh realities, the agency adapted and evolved. They actually shifted from being these fierce Cold War competitors into true global collaborators. They partnered with Russia, Europe, Japan, and Canada to build the International Space Station, an actual permanent laboratory orbiting our planet. At the same time, NASA became the undisputed leader in robotic exploration. Think about those incredible Mars rovers like Curiosity and Perseverance, hunting for ancient life. Or the Hubble and James Webb Space Telescopes, literally rewriting our understanding of the universe's origins. And speaking of robots, this robotic spacecraft heritage brilliantly highlights NASA's huge pivot toward unlocking the outer solar system. By deploying robotic marvels, like the New Horizons mission, which finally gave us our first stunning close-up of Pluto, NASA has been conducting this vital, deep space reconnaissance right at the freezing, dark edges of our cosmic neighborhood. To really wrap your head around the mind-bending scale of these robotic explorers, let's talk about Voyager 1. After more than 38 years in continuous flight, this probe is 134 astronomical units away from Earth. Let that sink in for a second. That means it is 134 times further from the sun than we are. It's carrying that famous golden record of human history, pushing the absolute outermost boundaries of our reach into deep space. We can actually visualize this immense cosmic distance by tracing the specific trajectories of these spacecraft as they confidently navigate out toward the distant Kuiper Belt.
It's essentially the ultimate map-making project. We're doing solar system cartography, charting out these ancient icy dwarf planets and space rocks that basically hold the leftover building blocks of our early solar system.
Now, looking back toward Earth, to make all these crazy future missions even possible, NASA had to completely overhaul how it operates. Historically, NASA built practically everything internally. But today, it's a totally different ballgame. They are eagerly partnering with private companies like SpaceX and Boeing. This shift is a total game changer because space exploration is wildly expensive. These private partnerships drive innovations like reusable rockets, which drastically slashes costs and rapidly accelerates what we can actually achieve. And that modernized collaborative approach is the engine behind NASA's biggest current endeavor, the Artemis program. The goals here are just spectacular. Artemis isn't just about planting another flag. It's about establishing a permanent, sustainable lunar presence. They're going to send the first woman to the lunar surface. And for a lot of us watching, this is going to be the very first time we see humans walk on the moon live. But the real kicker? Everything we learn living on the moon is vital preparation for the ultimate leap, human missions to Mars. So using the moon as our stepping stone, we can actually map out humanity's long-term timeline. This is where it gets really exciting. The roadmap shows the present Artemis lunar goals carrying us through the late 2020s, but then we scale way up. The target is the inner solar system and Mars by the year 2050. And looking even further down the line, NASA is already laying the conceptual groundwork to expand our human presence deep into the outer solar system by the year 2100. However, as we look out toward that bold, almost sci-fi future, we have to face some brutal biological constraints. Deep space is a harsh place. The radiation environment is measured in units called sieverts, and out there, even a relatively short trip exposes astronauts to the equivalent of thousands of chest X-rays. Add sustained zero gravity to that cosmic radiation, and you've got massive, massive hurdles standing between us and a permanent human presence on Mars or anywhere beyond. So we've journeyed from the sheer paranoia of the Cold War space race all the way to charting humanity's survival out to the year 2100. But to make this deep solar system exploration a reality, we're left with a massive question to ponder. What radically advanced propulsion and medical technologies are we going to have to invent to overcome our own biological limits? I mean, we started with a satellite the size of a beach ball. How far will our ingenuity take us next?